Okay, awesome. I think I am live. Great. I'm just gonna pour myself a little drink and we will get started. So I see there are four concurrent viewers. I want to know if my audio is alright. I don't know if there are any issues, if you can hear me. My guess is that you can hear me alright, but I might be wrong. Okay. Okay, let's get started. Let me check my OBS. Everything seems to be okay. Good. Okay, so what am I gonna be doing today? The point of today's live stream is to teach you, teach anyone who wants to know. This is gonna be saved on YouTube either way. Um, on how to use Rust to parse and work with CSV files. So I think many people that want to get into Rust probably don't have like much of a practical scenario on how it is to work with Rust, especially for CSV files, which is such a common how do you call that, data format for us people that work with data. So the point of this live stream is to kind of get all of you on sync on how to use Rust for anything to do with data. So I'm gonna have chat. I'm gonna be kind of taking a look at chat at any moment. Just if you want to send any questions or anything, I'm gonna be trying to look at chat as often as possible, but there might not be any questions or whatever. So if you want, just go ahead and ask. Okay. So I'm gonna go here into my projects, CD projects, and I'm gonna start a new cargo project. So a new cargo init, and let's call this CSV tutorial. Tutorial, great. So now I'm gonna see city into this CSV tutorial, and there you go. I'm on my little tutorial folder. Great. So I'm gonna go ahead and start off by taking a look at our main RS. Again, we have absolutely nothing right here. But what I want to do is slowly trying to add things. So what CSV are we going to be reading? There are many CSVs we could choose from, right? I'm going to start here a new incognito, just to kind of not leak anything that I don't want to leak. Good. So let's take a look at some data sets. So I'm going to go start out with perhaps Iris, I think is the Iris dataset. Is probably the best one to get started with. So if I just go here, I'm into Kaggle. I think I would have to log in. I think I'm just gonna, yeah. I mean, I think almost everybody has Kaggle, but let's look for an open version of Iris dataset GitHub, right? So here on GitHub, here we have iris.csv. Perfect. Let's use this one. So let's download this CSV. I'm gonna go here. I'm gonna open my terminal. I'm gonna do wget. I already had like a version of Iris downloaded, but I'm just gonna paste it here, and boom, I have iris.csv. So let's go into iris.csv. I think this is pretty self-explanatory. So we have all of our column names, and we have like the different values. Great. So I think that's good. Okay, let's go back into our main RS, and let's start doing, okay, what do we want to do? So if we want to read, right, a CSV file, in Rust, we could do a lot of things, right? So kind of like one thing you could think, right, is, okay, let's create a struct, right, that is an iris row, right? And what are we going to do? Thank you, Copilot. I think Copilot went a step ahead. So we're gonna want our column, like the different columns for iris. So this is like one option, right? Create a struct, where we have sepal length, sepal width, petal length, and petal width, and our species, right? Which in this case is a string, just like to kind of be open about it, right? So this is like the main option. So let's map it into here, right? Another option is, what if we don't know like the column names, right? So, and again, I don't think if you really don't know the column names for your data, don't use Rust. Unless you want to do specific things with specific, like unless there's a reason to, I wouldn't, like if you're just gonna explore data, don't use Rust. Use R or use Python. If you're gonna be building something with Rust, make sure it's something for like you want performance or you want like a very stable service. But for now, let's stick with this struct, right? So how could we read a CSV file into an array of iris row? So this is like our main question, right? So we're gonna add some crates, right? So we're gonna do cargo add, and we're gonna first add Certi. And if you don't know what Certi is serialize and deserialize. It's gonna allow us to basically read data in many formats. But Certi doesn't give you those formats. Other traits use the Certi kind of middleware, let's say it, or like the Certi interface to deserialize and serialize into different formats. So let's add Certi with the feature flag derive so that we can automatically derive it. And let's also add cargo add, let's add CSV. So CSV, and yep, I think that's it. Right. So here I added CSV, as you can see, cargo add CSV, and we added Certi. So I think that's enough for us to start with. So let's use Certi, and let's bring in serialize and deserialize. We don't have questions yet. Okay, good. And now we're gonna derive. Let's derive debug, sure. Deserialize and serialize for our iris row. Okay, so now what that means is that this struct now has an interface or a trait that allows Certi compatible crates to serialize and deserialize from and into it. Good. So now let's go ahead and open our CSV file, which in this case we're going to have to create a let iris reader, for example, or let's just call it CSV reader for the sake of it, equal to CSV : reader, and we can call it from path, right? And we can just call in the path. This is like the simplest way to do it. And I'm going to do an unwrap. Again, in production, don't use unwrap, but we are experimenting, so it doesn't really matter. Okay, great. I think you can look at the code right there. Yes, perfect. There's no issue. I'm trying to get the text size as big as possible, just so everybody can read it. Okay, so we have our CSV reader, right? We're gonna have to make this probably mutable. So I'm just gonna put the mutable right here. So let CSV reader, blah, 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 equals CSV reader from path, iris.csv, right? So now what can we do? So we're gonna want to collect the rows into a vector. So Copilot is kind of going ahead, but let's just start with let iris, let's call it rows, iris rows equals to CSV reader. And now we're gonna have to start getting into the records. So here we have our records, but this is like the string records. Right. Okay. I think we have here now, and now we map. And we do r-dat. No, but how do you call that? I think I'm making a mistake. I am very sorry. Deserialize. Yes. Okay, it's deserialize. Okay, so if I wanted to do this, let's mute iris rows, right? Let's do CSV reader dot deserialize. Sorry, it was not the other one. Dot deserialize. And what do we want to deserialize into? An iris row, right? So if we call this here, this is a records, right? So now if we do iris rows dot next, this is an iterator, and we can do anything we do with iterators with this. So we can do, for example, iris rows dot count, right? And we can call this let n rows equals iris rows dot count. And now we can print the number of rows. So let's run this cargo run. It's compiling. It's the first time compiling, so there you go. The number of rows is 150. And as you can see, this is what I call perfect data. This data has no issues. Species is effectively string, right? And petal width, sepal width, there's no values, there's no missing values. This is perfect data. And as you can see, for reading perfect data, we have absolutely no issue. This is super easy to work with. So we can do with these iris rows, we can do basically whatever we want. The thing right here is um, we don't know whenever, for example, if we do next, let's call it let first row, right? This is an option result, right? Because it's gonna iterate until there's nothing left, right? But inside that, it could fail, right? We don't know if it's able to read that row correctly or if it's not. So we have an option result, and inside of that, we do have our iris row. So we're gonna have to kind of how can we work with that, right? So we can use kind of some of the functional approaches or some of the functional, how do you call that, benefits of the functionality. I have no idea, features of Rust. So we could map, right? And inside this map, we could do R, and we know map is we're gonna have the result, right? Or we could do, for example, try collect, but I think try collect is unstable. Yes, we definitely don't have this. Yeah, we'd have to use this inside some sort of for loop. But for now, we can just call unwrap. So we can do map r.unwrap, right? So we're gonna unwrap the result, and we're gonna then collect it. So collect into, and I don't think we would have to mention this. I think it will assume that it's a vector, or apparently not. So we could just remove it here and collect into a vec of iris row. Perfect. So now we have our back of iris rows, and now we can do with it whatever we want. If we run it again and we do iris rows that count, right? And we could print, oh, this is print, right? Print iris rows dot length, for example, to see the length of the vector, right? If we run this, it's 150, perfect. So now we can actually start doing things with our data, right? We can start. Is read seeds from Rust faster than Vroom? I hadn't seen that comment. Let me zoom in. I'm gonna actually open pop-up chat. I think this is the best way to do it. Yes. Okay. So is it faster than Vroom? Likely. But it's different. It's different, right? So with this form of reading CSVs, we're basically making it like we're telling Rust, this is the structure, do it into this, right? And that's all we're doing. We could do a little benchmark later on, I think, once I'm done like explaining it. But I think I think we could absolutely do it, like do a little benchmark on how it works. I think that would be awesome. But yes, it should be really fast. Okay, so now let's say we want to do some additional things. For example, we want to, I don't know, count, like get the average per group. Right here, there's many ways of doing this, and here the ecosystem is not like there's not a particular data frame library except for like polars, sorry. But we could start actually manipulating this data. But again, this is perfect data. There's not really much to do with it in terms of getting the results we want. Right? We could like do a filter. We could do many things, but it's not really something very interesting. What I think is interesting, and I think what is cool, is when we have non-perfect data. So let's get some non-perfect data. So my idea for non-perfect data would be, I think I have it here, Kaggle, Airbnb. I think here it is. Airbnb global listings. So this is a little data set. I'm going to pop the link in chat. Data set. Great. So I just sent the link to the data set in case anybody needs it. This is definitely a non-perfect data set. So if we take a look at like the first couple Last scraped. This is the date where it was the. No, I don't think it was the Airbnb one. Let me take a look at what data set it was. Give me 1 second. I'm gonna put my desktop. Oh yeah, it's my bad. It's not the Airbnb listings. Forget that message. It's actually a Starbucks review data set, the one that I wanted to use. Yeah, so just ignore that message. I don't think I can delete it. Yes, I can remove it perfectly. Okay, so Starbucks review data set Kaggle or Kaggle, how do you pronounce it? I have no idea. Here it is. Okay, I'll resend it. Perfect. So I just sent here the link. So if we take a look at the data here, look at, for example, the review date. This is not a date format that would usually work for anything that we're doing, right? Here we have data that's 1 NA. So what does NA mean? We also have image links. We also have no images. And look at image links. Image links is an array of image links. So based on that, we would have to, okay, what are we going to do? How are we going to read this data correctly? So I'm going to go ahead and download it. We're going to go here and we're going to put it on our, what was the name of the little CSV tutorial, right? And here I'm going to call it, yeah, archive.zip is all right. Perfect. Now I'm going to do unzip archive.zip. Right, we have our review data. Let me remove the archive.zip, and here we have our reviews data. So let's take a look at the reviews data. We have name, location, date, rating, review, image links, right? And we have all our data. So now this is non-perfect data, as I mentioned earlier. So let's try to do the same instead of iris. Let's replace it with our non-perfect data. So let's call this review, right? Because every row is a review. That's kind of like the point. So what columns did we have? Let's do head reviews data, and here let's go toward the first row, heads, head, and 1, right? And 1, right? Okay, so we have name, right? Let's do it a string. Let's do location, string. Let's do date. String as well. Let's do everything a string, right? We have review string and we have image links string. Okay. So Rust doesn't really like camel case for struct fields. So let's do what it suggests and rename it to review, right? So here we have our little columns. Let's try doing the same thing, but instead of deserializing iris rows and instead of reading iris.csv, let's do reviews data.csv. So reviews data.csv. Great. And now let's just call this review rows. Perfect. So if we try to run this, we're going to get an error immediately once we run it. What is this error? It says deserialize error. What does it say? Line 1, record 1. We're just getting missing field date, right? Because on our CSV, it's called date with a capital L, with a capital D, and on our struct, it's a lowercase d, right? Blanks. Oh yeah. Oh, I'm so stupid. Thank you so much. Okay. I'm gonna have to go back to what I'm doing. Okay, so I downloaded the data, right? And here I unzipped it, and here is the data, right? So we have name. I think you can look at the screen right now. I think. Thank you, fixing right now. Yeah, you should be able to look at it now, if it's not that far back. Yes. Okay. Perfect. Okay. Thank you so much. Thank you so much, everyone. Okay, so thank you, Nevin, and thank you, Super Shiny. Okay, thank you so much. Okay, so this is our data, right? We have name, location, date, rating, review, and image links. Um, the data here is very non-perfect. So if we take a look at the data set, right? We can see that date is not like a year, month, day, or a day, month, year, or a month, day, year, or whatever. It's reviewed space the abbreviation of the month dot space the day comma the year. And this is like a very common thing for anything that has to do with data. We have a lot of things like this. For example, we might also want to, for example, here we have state, like the city and state, and we might want to separate those into different columns or into different things, right? Um, what I want to do is read this data correctly, right? So if we go back to our main.rs, here we have our struct review, and here I just put like the names of the little different column names, right? If I do here the first row, we can see there are some differences. For example, date has a lowercase d on our struct, and on our data it has a uppercase D. The same with rating, review, and image links. So if we try to run this, we're gonna immediately get an error. It says there's no field called date. What are you talking about? I think we're on par on what we were right there. Thank you again so much for the messages. Okay, so what can we do here? We can use serde to our advantage. So we can do serde, and we can do rename, right? And we can say that don't call this date. We call like date lowercase, call it date uppercase. So as you can see here, if we try to read it now, if we run, now we get a different error. It says missing field rating. So we would have to do the same for rating, right? So if we do serde rename rating, serde rename review, and for image links, we would have to do the same. So it would be serde rename equals image underscore links. Perfect. So if we do it now, it reads our CSV. And we could do here like print, red, so many rows, right? We're going to print ln, read, or red, reviews at length, rows. So if we run this, it should say that we rate at 150 rows. Perfect. Perfect. Okay. Thank you again for telling me that it was a blank screen. I'm going to pin this message with the data set. Perfect. Awesome. Okay, so let's continue. So now we kind of told Rust and serde how to manage the data. Can you give me 1 second? Okay, I am so sorry. I am back. Okay, so we've told Rust and serde how to work with our data. So we have our struct review. This is kind of like what we want to read and how we want to read it, right? And it effectively read it. But we have a problem. Everything is a string, right? And we don't want everything to be a string, right? Date is a date. Date is not a string, right? We could start like printing out, like let's do reviews rows dot iter dot take. So we're gonna iterate through our review rows. We're gonna take the first 10. Let's do our first 3 rows, for example, and for each print it. So if we do this now and run, as you can see, we printed our rows. We have name, location, date, etc. But what if we wanted to order the reviews by date, for example? I don't know if they are ordered. I have no idea. They seem to not be because September is before July 16th, which makes absolutely no sense. So we want to order our data, for example, by date. How would we do it? It's a string. We wouldn't get any good results if we tried to. So let's convert our date to a date instead of a string. So we're gonna add chrono, which is like the little library that you usually use for anything to do with dates. And I forgot to add 30. So we're gonna add it with the feature flag 30. There you go, perfect. And now let's switch this to a chrono naive date, which is a date without a time zone in this case. We could add a time zone later. And I'm just gonna go here and tell it to replace with a fully qualified use, just so we have like easier to read. So we have review, name, location, date, rating, review, image links. And now date is a naive date. So let's try to run it. Cargo run. What do we get? We get an error, right? So I'm gonna see if I'm gonna move my head over here, so that you can read the full error. So we have error deserialize, byte 45, line 1, record 1, deserialize error, field none, message input contains invalid characters, right? Because what? Our date column is not a date. Our date column is reviewed September 13th, whatever. Right. So how can we correctly read this data? So we have a couple options, and there are some options that I like more and some options that I like less. So we could call this, read it again as a string, and call this, for example, review raw, right? And we could collect this into a vector of review raws. And then we could create another struct that's called like review correct and do the manipulations ourselves. And that's what you would usually do in R. For example, in R, we would read the data, then we would mutate it and do some things. And then after that, we would kind of pass in our data. The thing is that in Rust, that's not really my preferred method of doing it. So I'm going to teach my preferred method of doing it, but if anyone wants to see a different method, we could, but the other method takes a lot more time, because since R has specific defined types, we would have to define a type for every single intermediate step in that case. But here we just want to read correct data, right? So let's start by creating a function that turns our little date string into what? Into an actual date. So let's create a new file. Let's call it data. Let's call it date converter, dateconvert.rs, right? It's going to tell us it's not included on the file tree, so we have to go back into main. And let's actually touch source live.rs. Let's add a live.rs so that we can kind of, so let's go back to our live.rs and do mod and add our module date convert, right? Let's make this public so that everyone can access it. Perfect. Okay. So let's start by use chrono naive date, right? And we're gonna have to start by creating a little function that converts our type. So let's create, let's actually start by doing some test-driven development. So I think that would be pretty cool to do. So let's do a little testing. So to start a test in Rust, we do hashtag and start CFG test. Here we create a tests module, and we use super to bring everything in the upper module into this under module. Perfect. So let's create a little test. And let's just cover for now one little test. Test date convert, right? So we're going to have our const date stir, sure. And let's call this, let's just copy it directly from our CSV. So I'm going to go here and open up our reviews data.csv. I'm going to copy one of the strings of the date, and I'm going to paste it right here. Awesome. Okay, so we have our constant date stir, right? And now what we would have to do is let converted date equals, so let's create first our function, public function, convert date, that takes in a date stir and returns a naive date. And let's do this to do. Awesome. And let's actually do a result, because, or an option, because it could potentially fail. And later on we might add, so let's set it to none if it fails and to some if it works. So convert date, we're gonna call convert date stir dot unwrap, because it's an option, remember. And here we would assert that both of these are equal. Awesome. And here it's opt and unwrap. Okay, so this, just to kind of be clear, this little function from year, month, date, opt basically lets us give it a year, a month, and a day. And it could fail because we could give it, I don't know, the 13th month, and this would fail. So we have to unwrap it. But we are 100% sure this works, so we could do like expect invalidate, something like that. Yeah. Awesome. Where to start looks pretty intimidating. Yeah, so I understand that it looks pretty intimidating. And if I'm going way too fast, just tell me to slow down. I could absolutely slow down. I would start by reading not all the book, not all of the book, but like at least the first like 10, 12 chapters of the Rust book. So if you just look up the Rust programming language, the first link is the book, and you have a lot of information. But I would start building. Like, how did I start? I started by building something, reading a CSV, like what I'm doing, and kind of understanding, like looking up tutorials. Okay, I'm getting an error. How do I read the CSV, for example, and all of that. But okay. So here we have test date convert. We created, this is just creating a test, right? And why do I want to test? Because if I do here cargo test, I want to, it fails, right? Because it's a to do, it's not implemented yet. So how can we start? Okay, so we have our date stir. So what would we want to do? So we would want to probably, first of all, remove the reviewed part, right? So first, let date stir equals date stir dot trim. So I don't know why my LSP. I'm gonna restart neovim and vim and convert date. Sure. There you go. Stir dot trim start, and here we're gonna be able to stream start matches, returns the slides with all the prefixes that match up and removed. Okay, so we're gonna remove this prefix, reviewed space, right? Awesome. So now we have something, right? We could even like create a different function, remove prefix, just so we can start like testing part by part. And we could say this is an inline function. Don't worry about it. It just trust me on this, right? So we could do date stir equals remove prefix date stir, right? And we could do here add another test, and we could do function test remove prefix. Let's send this const out here. Remove prefix, right? And we're gonna assert that our, okay, what happened here? Yes, my bad. What happened? Right. So this is still a to do. So for now, let's just return a none. Right. So if we run this, one passed, and which one passed? Our remove prefix. So we know that our program effectively removes the reviewed prefix. Perfect. Okay. What would we have to do next? We would probably have to create some sort of type that kind of takes the like can match the months to the different how do you call it, to the different actual days of the month. So now we're gonna make use of an enum. So we're gonna create an enum, and let's not make this public. This doesn't need to be public. So enum months, right? Or let's call it dirty months, right? Because they're kind of dirty. So let's call May, right, is one of them. We don't know about any other for now. I'm sure if we go into our CSV, we can kind of find a few of them. So I think my face is in CSV, so I'm gonna move my face again. I'm gonna move it down here again. Perfect. Okay. So we can hear we have sept, right? We also have which ones? July. We have June. We have August. So Aug. Let's see which other months. April is full, so April. December deck. Nov is for November, right? October, September, October, November, August, July, June, May, April. Where's Jan? There's no Jan. Yeah, there's a Jan. February is FEV. What other ones do we have? Fev. How's March written? March? March is full, so March. And I think we're done here. We have our 12 months, right? 0 and 2, 11. Yes. March, comma. Perfect. So here we have our months, right? And again, we can make use of SERDI to help us match those automatically. So we can use SERDI, deserialize and serialize, right? And here we can tell it to derive, serialize, and deserialize. Perfect. Awesome. So we imported SERDI, we use it, and here we tell it to derive this for 30 months. Since this is an enum, and months basically match to a number, we can actually do this as equals 1, equals 2, right? For every single one of the months, we can tell it what number it's supposed to match against. So 6, 7, my bad, 7, oops, 8, 9, 10, 11, and 12. Awesome. And we can tell it to so these ones are basically represented by 1 byte, and that's usually optimal. The thing is, and we could do like a cast conversion, wouldn't really matter much. But our function from year month day out takes in the month as a U32. So let's tell Rust to represent this wrapper as a U32. And that's it. Now it takes up. Now it's the type that we want, right? So we have 30 months. So now what we're going to want to do is, for example, match those values. And I think SERDI doesn't really help us much here. Actually, I'm not going to use SERDI. Okay, so what we're going to want to do now is separate into 3 parts this little string after we remove the prefix, right? So let's create another function. And let's call it separate. Now we could do it in a more functional way. So we could do date stir now, right? And we could split white space, right? So let's do it. So split white space. Awesome. But in this case, let's create a different function. So function date stir into parts, something like that. So here we're gonna have to take our date stir with no prefix. But we know it has no prefix. Let's just set it like that. And this we can return, for example, a tuple of 3 different stirs, right? Stir, stir, and stir. Something like this. And we could do, for example, here are let mute parts exactly date stir dot split white space, because okay, so there's another thing that we are missing, but we can take care of that logic. So our little test has because some of them, the abbreviations of this data actually has more things than so for example, knob has a dot, right? And dec and fev, the ones that are not abbreviated have a dot, but the ones that are that are and do not. Okay, that's something new about the data that I hadn't thought about. Okay, so let's handle that case, right? So let's split white space, right? Perfect. And let's do let month equals parts dot next, day and year. So I think actually we start with day and year. Yes, awesome. So as you can see what I am doing here, and again we could wrap this inside an option. For now, let's wrap it inside an option because this potentially fails, right? And we can call in a little question mark operator to kind of unwrap it and send it up if it fails. We'd have to wrap this in some. Awesome. Okay. So here we create our date stir into parts, and basically it's gonna divide it into 3 parts by white space. So now let's do this. Let month stir, right? Day stir and year stir, day into parts. So here we have again our different variables: month stir, day stir, and year stir. Awesome. So now we're gonna want to like parse those right into things that we can actually use. So how can we parse our dirty months? First, the first thing that we would have to do is create. We could create another function, right? Or we could use like Rust traits. So we can implement a new trait which is standard stir from stir. So this is going to allow us to use the parse method for dirty months, right? And here we would have to do function from stir, and I think this works. Awesome. So I don't know if you can hear like some noise. My neighbors are doing a remodeling. They're kind of, so for now I'm just gonna return no error. I think this sounds about good to me. Okay, awesome. So let's continue. So we're gonna have to match, right, our different strings into our dirty months. So like even here, for example, I'm using like the abbreviated names just as they are, just to make it easier for me to remember. But you don't have to. You can do whatever you want. So now let's do Jan. So we know Jan is an abbreviated one. So if we go back to our CSV, we can see that Jan has a dot, right? So Jan dot in, come on, Copilot, I don't want you. Okay, dirty month, January, right? Feb dot is February, March is March, April is April, May is May. Okay, I don't know how that sounds. I'm gonna try to listen to myself. So I think actually we start with day and year. Yes, awesome. So as you can see what I am doing here, and again we could wrap this inside an option. For now, okay, okay, that sounds pretty bad. I am so sorry with you. I have no control over that. Let's just continue. We're already way into it. Okay, so May, June, right? July, Aug dot, right? Sept dot, Oct dot, Nov dot, and December dot, right? And Ross is telling us, hey, this is so bad. I am so sorry. Okay, it seems to. Ross is telling us, hey. Ross is telling us, hey. Okay. I don't know what to do. Okay, seems like I can continue now. Ross is telling us, hey, there are an infinite number of possible strings. What do I do in the cases that are not covered here? So we would have to tell it return an error, because if our string is not in here, then it's not a valid one, right? And we could even return, like here in our error, return, for example, a static stir, and just tell our program, hey, if there's an error, so if anything else, error, invalid month, right? You could absolutely do this right here, like that. Awesome. Cool. So now, we'd have to convert our month, like this, our monster, into our month. So let month equal monster dot parse dirty months. Okay, awesome. So basically what I'm telling you here is take our monster, parse it into one of our dirty months, and I don't think calling it dirty months anymore makes a lot of sense, but it's fine, right? And then we do an OK to tell it, hey, if there's an error, turn it into a none and pull it up. Awesome. So now we're gonna have to do the same, but for our dayster and yearster. So again, remember there's like a little comma in our little CSV. Where's our CSV? Here it is. As you can see, we have 31 comma 2022. 2020, sorry, in this case. So we would have to remove that comma, right? And that's usually on the dayster or yearster. So here we would have to day again. Here, we could again remove this into another, but I'm just gonna do it here. Lay dayster dot trim and matches. Awesome, trim and matches. And we're gonna want to remove this little comma. So let's just do it as a character and then parse it as a U32. Awesome. So we're taking our daystar, we're removing the end if it matches this, and then we're gonna parse it into an unsigned 32-bit integer. Awesome. So now let's do the same for our year. Let's just parse it as a U32 integer. So now we have our month, our day, and our year. But we have one problem. One problem. This is a dirty month, and this is not really, how do you call it? This is not really an I32, which is no a U32, because that's what we need for right for a month. This needs to be a U32. Awesome. Okay, perfect. So this is not really a U32. What can we do? We can basically implement some sort of method that allows us to convert from dirty months into an I32. A U32, sorry. So here we use wrapper, which means under the hood, dirty months is a U32. So we can basically do this as U32. And this will cast our monster or our dirty month into a U32. We can do that. So we can do it by casting, or we could create like a hidden, because people will probably not know this. We could do like an implement into U32 for dirty months, and we will tell Rust exactly how users should do this. So into self, and this is basically what we want. So under the hood, we're casting, but we don't want our users to be casting data, right? So we'll just create this into method, and here we can call dot into, but it's not gonna know what to turn into, right? So we can tell it month. We can go one step ahead. So here we're telling it to convert it into something, but Rust has no idea what to turn it into, right? What is month? So it's a dirty month, but we're telling this dirty month, and let's change dirty months to dirty month. Perfect. It's a dirty month, but we don't know what to turn it into. So once we actually use naive date, year from, and here our year is in I32, sorry. Year, month, date, opt, right? Now we pass our year, our month, and our day. Now it knows what to turn it into, right? Because here it knows month has to be a U32, so now it knows it has to turn it into a U32. So now if we test other functions, so if we do cargo test, it passes our test. Awesome. We could repeat this many times for many different possible dates. So if we do here datester 2, for example, and datester 3, I don't know if this is the best method of doing it, and we change this to knob dot for November 31st 2020, for example, just creating some random dates. And let's do here Jan dot for January 1st 1999, something like that. And we could basically here create like that converted date, and we could like just pop in this into the assert itself, because we really won't need to. So we could thank you Copilot and thank you Copilot. And if we do cargo test, we failed one test, huh? Interesting. What did we fail? On date convert, we have a non-value on line 88. So here our date cert is not being properly converted. Okay, so why? So reviewed knob. Let's see. We have knob dotted. From what I think, it should probably work. So I have no idea why this. November 31st, 2020. November 31st, 2020. Huh. Okay, so it might be time to implement some better error handling because I have no idea why it's failing. Like, what's the reason for it to fail? So let's turn this instead of options into results. So I'm not worried about a remove prefix one. That one should just work. Here we're telling it's invalid month. Awesome. And here, basically, instead of returning an option, I'm going to return a result. And I'm going to return, again, a static string as our reason. So here we would have to do okay or, and here would be no month, right? For this one, it would have be no day, and for this one, it would be no year. Awesome. And here we would have to return, instead of sum, it would we have to return okay. Awesome. And now for convert date, we can actually start here result and do the same. Let's return the error as a string just for simplicity's sake. It's not, so here we don't have to do the okay. We can just do this, right? Parse. Here we would have to tell it, because parse returns an error. Let's see if I can do this. Can I convert this string to okay. Let's do map error, invalidate, sure. And the same, let's do map error, invalid year. Awesome. And now here we would have to okay or invalidate. Awesome. So if we run this, what's the reason for error? Invalidate. Huh. Some year, month, day. Huh. Okay, that's very interesting. So the error is here. We could do like some debugs. We could do debug month, yep, and just kind of see what's the problem. Month 5, day 26, year. Month 11, day 31st. There's no November 31st, right? No, I'm so stupid. Like I'm actually like really dumb. Calendar. Let's just look for a random calendar. Yeah, I just want to see a 2023 calendar. I'm so stupid. Does November really only have 30 days? Okay, I am stupid. I am actually stupid. Okay. November 30th. There you go. Now what's the error? Invalid date again. January 1st, November 30th. That's a valid date. Come on. Don't that's a valid date. 11/20, right? And here we have a year or month and a day. So what's the problem? Oh yeah, I'm still putting here. I'm so stupid. There you go. It passes all the tests. There you go. I'm dumb. Okay, it passes all the tests. Awesome. As you can see, I'm not perfect. I make mistakes, especially when I'm trying to explain stuff. I forgot November only has 30 days. Okay, awesome. Let's continue going. Okay, so we could put this into another function, we could create a little function and we could inline it, right? And we could tell it parse day stir, right? And we can pass here a day stir, which is a stir, and return a stir, or a result with a stir, or an error message. And we would just copy this. And here we put a new guys here. Yeah. But okay, day equals this, and return okay day. Oh yes, we don't return a stir, we return U32. U32, awesome. And I think like that we should be able to just put it like that. Awesome. And now we would just call let day equals parse day. And we could even use the same function for a year, but again, we don't need this trim, so we could just use like the default parse. Whatever. Both work, alright. Yeah, let's create our a little inline function and call it function parse year stir. And yep, that should be okay. So year equals parse year stir. Awesome. So our function looks pretty okay. We first remove the prefix. We split into month stir, day stir, year stir. We parse our month stir into a dirty month and then into an I32. And we do the same for day and year. And here we don't need the debug anymore. Awesome. And then we just try to convert into a year, month, date. And if it doesn't work, we get an invalid date. Awesome. Okay, cool. So, I don't think we have any other questions. No, we don't. Okay, awesome. Okay, so moving on, we want to use this convert date function to actually deserialize our data. So let's create a function, public function, right? And here we're gonna have to write some boilerplate. So deserialize date, and here's where we're gonna need to do like some weird things. So we're gonna need to add in a lifetime D and a deserializer, right? D result naive date. Awesome. Okay, and we would have to use certi deserializer. Awesome. And I think we would also need to call it here deserialize. Awesome. Okay. Yep. Okay, so here, don't worry about the boilerplate. Basically, what we're creating is a function that takes in a deserializer and returns something. In this case, a result naive date and a deserializer. So, what are we gonna do? We're gonna date stir. This is gonna be a stir, and we're gonna call deserializer. Deserialize. I think this is deserialize stir. No, but here we would need a visitor. Okay, so we do deserializer. Deserializer. Okay, yes, that's how it is. So we're gonna deserialize that into a string slice. So we're not doing any extra allocations, just deserializing into a stir, right? Into a string reference. And now we're gonna convert our date stir into whatever we want. And in case there's an error, we're going to match it into a customer. Right. Awesome. So this might look a little bit confusing, but trust me on this one. Basically, what we're doing is here, the serialized date, taking the serializer. We use the function we use to convert the date into a date. And if there's an error, we send it into a SERDI custom error. Awesome. So now, if we go back to our main, right, we can use CSV tutorial, which is hard create, date convert, and deserialize date, right? And here, take a look at this. Here in date, we pass in a naive date, and here we tell it deserialize with deserialize date. Awesome. So we're telling SERDI, when you deserialize this, don't do it by using default, like normal, how do you call it, normal date formats. Do it with my function. And if we run this now, it works. As you can see, date is now a date. So let's look at this from a closer angle. I think you can, yeah. So look, date is now a date. Date is no longer some string, some weird string. It's actually a date, and we can do things that people do with dates, right? So we could do reviews row that sort by key, our record, the date, right? And boom, it's sorted. So if we run it now, the first one is in 2000, 07, 19. The next one is in 2004, 1020. The next one is in 2004, 1105, etc. Now we actually were able to sort by date. Awesome. Awesome, awesome. Super cool. Super, super cool. Okay, I think that's good. So we took some data that has no order, and well, not, it has an order, right? But we took data that is not very clean, and we turned it into a date, into what it actually is. So let's do the same for example, image links, right? Because image links seems, and I'm gonna open the CSV, seems to be basically JSON, right? If we take a look here, we have no images, or I don't know if that's even valid JSON. Let's do JSON parser. Is single quote valid JSON, right? Let's do no images. Is this valid JSON? Expected token. Yeah, this is not valid JSON. JSON single quotes. String is a single string of quotes. JSON will raise JSON decoder. Yeah, this is not valid JSON. So we would have to basically find a way to. What format is this? I have no idea what format that is, but we can write something to parse that out. That we have absolutely no issue with that. Okay, so does YAML support YAML single quotes? I don't know what that is. Can I use single quotes in YAML? It seems like we can, but I'm not sure. Okay, so let's try something out. Okay. The good thing is we know we can assume some things, right? We know they are links, right? And we know they are comma separated inside those brackets. That's all we know. Okay. So let's create a new file source, and let's call this parse image links.rs. Right? It's not included. Let me include this in our lib.rs pop mod image parse image links, right? So here, let's start by creating, again, let's create a little test, cfg test. Let's do mod tests. Use super columns, And here we're going to have in here test and function test. Let's call it, how would you say this? Function test, parse image links, right? And let's create our function, parse image links. And this would taking links stir, right? And this should return a vector, right? A vector of URL. So let's add cargo, add URL, right? I added here URL. Let's add 30 just in case, and let's use URL, right? Just so this is gonna be a vector of URLs, and if there's no images, it's gonna be we have a decision to make there, right? We could make it an empty vector, or we could use NA, like an option type, to kind of define that. But that's our decision to make. Okay, so awesome. So let's start building this. So first, let's do a to-do, just so we don't get like big errors. And let's start doing what we do. So first, let's call this function unbox image links, right? Image links. And what this is gonna do, we're gonna do our image links, right? And we're gonna trim start and trim end. Awesome, it did it for me. Okay, awesome. So what I want to do is remove the first bracket and the second bracket from my image links. Right? Awesome. So we can even add like a little test for that. Test function test unbox image links. Right? And we could do here const image links x. And we could do here stir, and this could be equal to something like hello world, comma hello world 2, something like this. And we would assert that this is equal to this, right? And if we do cargo test, it should fail all but one. And oh yeah, it passed this one because we're not testing anything. Awesome, but it passes. That's all we care about, right? Then we're gonna want to separate like our little. We could even put this in traits. We could even like do it like that, just to make it a little bit more functional. But I don't think we care much about this for now. So we could do function, and we could do this split image links, right? And we're going to take our image links stir, right? And we're going to return a vector of stirs. Awesome. So what we're going to want to do is image links, image link stir, split it by, yeah, so we're definitely going to want to split it by white space probably. But we're okay. So let's do it like this. Split white space, right? Then we're going to map into each one of them. And we're going to trim the end in case it matches. We're going to remove this comma at the end, and we're going to collect, right? So as you can see here, we take our image string, we split the white space, we map through every single one of them, and remove the little end. And that should work, right? So now, if we test function test split image links, and we have this, we should get this, right? Cargo test. Okay, it failed. What failed? Okay, so here we have, oh right, of course, because I'm splitting in white space. I'm splitting where I don't want to. So we should actually split. We should split at. Okay, so split Um, the split take the pattern, yes. So we should do it at comma space, right? This is how we should split it. So at every comma split, we split, right? So we run this, now it should work. Awesome, it works, perfect. Okay, so now we have our separated little links. Now what we're gonna want to do is remove function, remove single quotes. Awesome. Basically, we take our image link, we remove at the start and at the end the single quotes. Awesome. And then, finally, what we're gonna want to do is function parse it, right? And what this is gonna do is it's gonna taking an image link, and it's actually I'm gonna return an option URL because it could fail, right? So here we're gonna do okay. Awesome. Awesome, awesome. Okay. Okay. We could put all of this into like a image manipulation trait just so that we can do like the cool functional programming thing. So let's do it. Let's do a little. It's only internal. Parse image links. Image link, right? Let's just call it like that, and let's add our unbox image unbox string. Sure, unbox image links, right? And we have split image links and right. Basically, this is what we're gonna do, and then we're gonna actually parse image link, right? And it's gonna return our option URL. And now let's implement this parse image link for stir. And I don't think we're gonna need a lifetime for now. Yeah, so I'm just gonna call in the little functions that I already created. Huh, yeah. I mean, function, function, split image links, and then remove the single quotes. Awesome. Yeah, so I'm just gonna replace the contents actually. So unbox, let's set it into this. Awesome. This would be self instead, right? Yeah. So parse image link, we take this one and we paste it right here. Awesome. So parse image link, goodbye. Awesome. And here we would actually turn in self. Awesome. Okay. Then split image links. Let's place it in here. This would be self again, and then the remove single quotes. We are just adding like the things we want and implementing it for stir. Awesome. Okay, awesome. Given this, we can do our parse image links like this. We could do link stir dot unbox image links dot split image links, right? Split image links. Then we're gonna, after splitting the image links, we're gonna map, right? Link, because image links returns a vector, right? Yeah. We're gonna do link dot remove single quotes dot parse link, right? This is something we should be able to do. Oh yeah, here we have to call it into iter. Awesome. Okay, and this should give us now. Okay, and then after this, we're gonna wanna collect into an option of back URL. Is this something we can do? Apparently, yes. Awesome. Okay, so let's call this let image links, right? And we could do this. Awesome. On. Yes, this would have to be an option of back URL. And we could just return this. Awesome. Okay, so now let's test our parse image links. So let's create our const image links. And here, let's actually put in some image links. So for example, https hello.com/photo.jpg. Hi man, it seems interesting. Not gonna lie, I have never learned ROS, but I heard it. Yeah, it's really powerful, especially for string parsing. It's awesome. Okay, so let's take a look here. So hello, and let's create another photo JPEG, right? And now let's assert equal that when we parse this, we get this. Cargo test. We got something. Split image links. Oh yes, we would have to call it image that split image links. Awesome. Okay, and here up here we would have to do the same. Image links dot unbox image links. Awesome. Awesome. It works. We are now being able to parse. Okay, so now we would have to test when there's an invalid URL with invalid URL, right? So if, for example, we have our no images, so no images, which I think that's how it's on the CSV, on the other CSV, no images, right? So if we have no images, this should just return a none. Works. Awesome. So now if we have an invalid URL, we're gonna get a none, right? What if we have like a valid or invalid URL and valid? So we create here, this should still return none, right? That's not really what we want. I don't know if this edge case actually exists. That's a good question, right? Because we don't know. What if none of them are valid, right? But I think this is a good compromise to make. Like, if there's no way we have no images, but again, that's something we can on implementation test out, create our unit tests, and go ahead and continue. Right. So we have our unit tests. We have our parse image links, right? So let's put this as public, and let's create again some sort of way to deserialize that. Awesome. So let's do pub function deserialize image links, and we're gonna repeat the same pattern. I'm gonna call here de d, and here we're gonna take in a deserializer d. Awesome. So here we have our pattern. Let's do use serde deserialize, and we're also gonna need to call in the deserializer. Awesome. Awesome. Here it is. Okay, so now that we have this, what we're gonna do, and we would actually want to return not an error, but like an option. So option back, right? But if it fails in another moment, because we don't really have anything that could tell us that this could fail. Okay, so that's something that I wouldn't know. Okay, because we could do a map while. Yeah, because here it's a take while. Okay, so instead of this, okay, let's add another condition, right? So here we have parse image link, right? So let's do a match here, and let's return here, instead of an option URL, let's return a result, right? So this would be a result of an option of a URL. Okay, that's what we want, right? Awesome. Okay, so here we're gonna match our self, right? And we're gonna do, if it's equal to no images, right, it's gonna return none. But if it is anything else, it's gonna try to parse it. And here we're gonna have to tell it. Let's do a static stir again. So here, that map error invalid URL. And we would have to put this all inside a sum. And this one would have to be okay. Okay, I know what's going on. Map error, right in here, we would have to do map URL into sum. Is this what I need? Try wrapping the expression. Okay. Okay. Expect a reference to stir, found it static stir. And here like this. Awesome. I mean, we could do, I think we could do the, no. Okay, awesome. This is what we needed. Okay, so if it's no images, we're gonna return. Awesome. Okay, so if it's no images, we're gonna return an okay none. If not, we're gonna try to parse it, and if it parses correctly, we're gonna return a sum with that URL. And if it errors, we're gonna return an error that says invalid URL. Awesome. Okay, so now here in parse image links, we would have to do, would have to collect into a result, right? So I don't know if Rust is going to be able to help us out with such a complex collect. Yeah, so result static stir. Let's see. Hope no, it's not able to. Expected option back. Huh. Okay. But here if we return a result of option static stir. Value of type can not be built from. Yeah, because we could return like a none. Because I don't want to unwrap it. I want to like try to collect it or return into. So this would be instead of a back. What's the best way to do this? So basically what we want to tell it is if there's a none, everything is a none. That's the thing that, because a none is basically equal to no images, right? So we could, I guess, filter map, right? And just ignore nuns. Yeah, that's an like a good question how I could build this correctly. I mean, I want a map, right? If I here's here an option of URL. Let links equals this. Okay, if I remove the result, I'm gonna get again an error because we are not returning a result. Because we are returning a result, sorry. And we don't have try like a try collect. But here parse image links returns a result, right? Yeah. So how would this work? Okay, I'm a little bit confused on the semantics right there. Expected result back option URL. Yeah. I mean, since this returns a result, you know, I don't have a try collect yet. But I don't want to map those. Because here in parse image link, in here, okay. Okay, so I think I know what the problem is. I think I'm thinking about this incorrectly. Okay. So here we have parse image link, which returns either an error because it couldn't parse a link, or it gets none, right? Or it gets a value or none. So it has three possibilities. Are there any? No, there are no questions. Okay. So here when we do into iter, we would have to collect this into a vector of vectors because here we have a vector and we're no, I'm wrong. I'm wrong. So I want to collect into a result. Let's look it up. Collect into a result Rust. Iterate on results. Let's see what we get here. Parse collect, right? Ignore the failed items with filter map. Collect the failed items with map error and filter map. So filter map errors that push, yeah, so this would push into an error. Failed the entire operation with collect, right? So if we just do collect, Okay, so this is the thing. Parse image links returns a result of an option of a URL. So this would have to be a result of a vector of options of URLs. But why can't it collect that? That's the question. Cargo bill, let's try it. Okay, let's see. Iterator item change to option URL here. Because parse image link, go to definition. This returns change the output to try to match the URL. Oh crap! I am so stupid. Result option URL. The static strs explanation. Okay, right. So let's just do this. Add map sum. Da 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 da. Okay, now we can actually do this. Okay. Can we switch option and back? Like, is this something we can do? Yes, we can. Okay, awesome. That's all I had to do. I'm so stupid. Okay, so links in here. Let's collect into this. Let's add here the question mark. Awesome. Okay. So if there's any option, we're gonna return just a blank. Elsewhere, it's gonna be a vector of URL. So let's try to test this. Cargo test. And here, this is gonna have to be an OK. Awesome. And this would have to be an OK of a none. Right. Let's see if it. Okay, it failed. For pass to fail. Okay, which ones failed? Parse image links. Okay, so why did it fail? Not implemented yet. Oh, yeah, absolutely. So parse image links. And we would just return this directly. I am so sorry about the noise. Let's see. Awesome. Let's run this. Awesome. It passes all the tests. So, what if I have... I'm going to ask the question now. Okay, so what if I have, for example, valid URL and valid. So what if I add here a valid URL like this? Would I still get none? I would. So that's not really what I want, or is that what I want? Because if any of these are blank, then it's going to return a whole blank. Else it's going to return a vector with actual things in it. So we could actually like do here a dot map. So in case it's okay. Yeah, let's do it like that. Okay, so here we're going to do a map, right? So if there's a link in it, so link, what we're going to do is that we're going to do the following. So if it's all right, can we do a filter map here instead? A filter map with a result? No, we can't. Well, we could just do a map and now do a filter map where we take link and we match link to if it's okay some link. We're gonna return some okay link, right? If it's none, we're gonna return none. And if it's an error, we can return some error, right? Can we do this? I'm just gonna leave it as it is. I think this is fine. Let's remove this test. Works. Okay. So this is gonna be the teddy behavior. If you find the no images string, it's gonna be no images. Okay. Awesome. All right. I think we have that now. We can create our little deserializer, right? Public function deserialize image links. Do the same kind of boilerplate, right? Awesome. And let links start. Awesome. So now we can go back again to our main. We can do here use CSV tutorial, parse image links, deserialize image links, and we can tell here that we can tell it that there's going to be an option of a vector of URLs, and we're going to tell it to deserialize with this function. Awesome. So now if we run this, we can see here we have image links none, image links none, image links none. And again, let's just let's not sort it because I want to see like the first couple rows. As you can see, we have some domain blah blah blah, port blah blah blah. It basically, this is like a debug way of printing the URLs. But we can print the URLs like in a more standard manner, right? We can take 3, we can do a for each, and do here record, and then for every record, take the image links, right, and iterate through each one of them and print them, something like this. And URL doesn't implement. Huh, okay. Yep, so as you can see here, we have URL with this, and if we do this for like what, take 10 for the first 10, we can see we actually start getting some different files. Awesome. And if we take those files, we could, I mean, in order to make them easier to print, we could just do here a .toString for, oh yeah, this is a back URL, right? So we would have to go through every image link. So L dot, because L is a back URL, right? So L dot iter dot for each. Awesome. So yep, as you can see, we have a bunch. We're getting actual image links. Let's do this for the first 100. Those are the first 100, right? And we could then like take this into like a single one, and but here we have our image links. And how like what's basically a better method of making this once we write our file? We could write this in a JSON, like the array into a JSON. That would be probably easier to work with in other languages, or in PostgreSQL we could store it in a like in an actual array. We could do like many things. But okay, now that we have this, now that we have our corrected data, let's sort it as I mentioned, and now let's try working into serializing things, right? So let's create a writer. So let's call this. Let's create this function. Let's put all of this into a function called read reviews CSV, right? I'm gonna put all of this in there, and this is gonna return our vector of reviews, right? And like this. So let's call this let reviews equals read reviews CSV. Awesome. Let's sort our reviews. Reviews.sort by key, date, and here we have to tell that it's mutable. And now let's write it. So let's create a function write reviews CSV. And we're going to do the same. So, but let's call this one clean. So we have CSV writer from path into a file called reviews data clean. And we're going to go, I don't like the for loop. Let's do it in a more functional way. CSV writer dot serialize. Or we would have to do reviews dot iter, right? Dot for each. And for each one of them, we're going to have to do CSV writer dot serialize. And we could, again, this returns a result. We could do it in a map, right? And do r dot, well, CSV writer dot serialize and collect. That would be a better method probably with the map. Can be built over an iterator of type blah blah blah. So here we would have to tell it it's a result of this and this, right? Awesome. And we could then call unwrap over the whole operation. Awesome. Can we do a try for each? Is that possible? Dot try for each? Apparently we can. Okay, awesome. Love it. Awesome. Okay. So now we can write review CSV and write our reviews. Awesome. So what I want to kind of see how it looks, how it works, is let's try running our program. Cargo run, right? We panicked. Where did we panic? Unequal lengths. Of course, because this is a vector, right? And the thing is that CSVs don't allow for vectors, right? So we would probably have to create a serialize with function or do something else in the process. That's probably what we would have to do. Or if we don't care about our last columns, I think we could write it with no headers. Is that something we could do? CSV writer dot with headers. How would you call this? Let mute CSV writer builder equals CSV writer builder new headers false from path reviews data clean dot unwrap. Okay, I think we could do it like this. I'm not sure. Yeah, unequal lengths. We're gonna have the same error, of course. Okay, so to fix this, we could write this into a JSON, right? So if we do here cargo add 30 JSON, which again, if we then write into a JSON, I think this would work because JSON does allow for things like arrays. So if we do 30 JSON serialize to string pretty reviews unwrap, and we let JSON equals, if we print it, cargo run. Yeah, it does turn into JSON. Why? Because links can be either null or they can be an array. But with CSVs, we don't have the ability to do that, right? So what can we do for CSVs? We could basically tell it how to serialize, right? So we have deserialize with, but we also have serialize with, right? So we could do Surday JSON. It's too string pretty. Sir, is this something we can do? This function takes one, but okay. Why were two arguments applied? Oh yeah. Okay, so we would need to create the function ourselves. Okay. So let's go back to our parse image links and let's create our serialize method, right? So public function serialize. I'm gonna close this. Serialize image links, right? And if I'm not wrong, yeah, it takes an S. The image links. So yeah, so we could join them with like a comma dot, but I think just making it JSON, I think, would be the easier way to do it. So we could even like serialize a stir, right, until no images. But I think simply leaving it blank would be like the better. So if it's none, it's gonna be blank, right? But if it's some, we should do 30 JSON to string links. And we need to do serializer dot serialize string stir 30 JSON to string. Awesome. And this I think would have to be our reference. Okay, what's wrong with there? So this string, this there's a result. Could not convert between map error, failed to serialize image links for some reason. Okay, so I think this should work. So serialize stir, serialize, yeah, stir, yeah, okay, I will leave it like that. So if there's links, put them into a JSON. If there's none, leave it as blank, or we could just leave it as a blank JSON or null. Like I don't know. For example, in R, if I go open here R and do JSON light from JSON null, okay, just turns into null. We could just go straight to 30 JSON. So serializer that serialize stir 30 JSON to string. I think this works good enough. Okay, now if we go back here, let's also bring here our serialize image links, right? And here in our image links, we could tell it to serialize with, awesome. There you go, it organized it for us. So our image links field, we're gonna rename it to image links, we're gonna deserialize it with this, and we're gonna serialize it with this. And if we do it now, as we were doing, so remove here this, it should run, no problems. Cargo run. It works. Awesome. So now if we open our clean CSV, as you can see, we have a date, like an actual date. It's sorted by our date and our image links. So if let's look for some image links. Null. Here we have our image links in JSON format. Here we have the problem that we're getting this. Oh, those are quotes. It's escaping the quotes. That's awesome. That's how it should work. Awesome. So it just works as it is. Okay. So we have our the clean version of our CSV now, and we could again separate the Sunnyvale, Texas into two columns, right? A state and city. We could do many more things, but I think that's all we need to do for this session. It was about 2 hours. I made some mistakes. It's not my best live stream, but I'm gonna try to improve for in the future. I hope you like this. If we do this cargo build release, And now, like, if we just time it to see how much time it takes to do all of this, time dot slash target release CSV tutorial, it's negligible. Like, it's so little time. The time it takes to read the CSV, do all the things. It's, well, how much time does it? 0.003 seconds. So that's what, 3 milliseconds? Is that how long it took? Yeah, about 3 milliseconds is the time it took to do all of this. And here we are not even doing parallelization or anything like that. So we're not doing, we're just working on a single thread. I'm thinking parallelization would make a lot of sense to this, for this. But yeah, 4 seconds, you're never gonna get that in R. For something like this, but this works absolutely awesomely. This is it. I was trying to explain things as much as possible, so sorry if this took quite a while. But thank you so much for watching the live stream. I hope you liked it, and see you in another live. Bye.